Hello everyone. Thank you for joining this presentation called Ideas to Code. And Living Lab Stratumscience is a project that I've been developing over the last year. And I'm going to try to explain to you how I go from some of the ideas that I have into the code that I create in order to make these kind of projects. And I would like to thank MadLab and the Future Makers Factory, but also the Eindhoven Festival for this opportunity and this invitation. But first, who am I? My name is Luis Ferreira and I'm 32 years old. I have a master's in computer engineering and I've been working mostly over the last years within the engineering world, as you would guess from Eindhoven. However, about 2 years ago, I started to feel the need to do some more creative things, have some more freedom that I didn't have within the engineering world. So I found out about creative coding and I became a creative technologist. And a creative technologist is someone that basically uses technology for fun and expression instead of a specific purpose. Within engineering, for example, you have a specific purpose. You need to make a machine go faster, produce something with more accuracy, something very practical, a solution for a problem. Within creative coding, and as a creative technologist, I don't worry so much about the purpose of the things that I'm developing. I'm more interested in how I express myself, but also how other people interact with technology. Can I make something that you hear sound more interesting? Can I make something that you see look more interesting by using technology, by using projectors, speakers, motors? All of these kind of things can be used for fun instead of a specific purpose. An example of this is one of my first projects, the Light Canvas. And the idea here was to paint with light in the most natural way possible. And this actually describes two things that I love, painting and light, and also color. So this was a bit of my first project that I really tried to combine what I learned over the last years in engineering, in electronics and programming, in order to create something that is purely expressive. There is no higher purpose to this project other than have fun and paint with light, because that's something that I was never able to do with any other project. Currently, I'm working on another public project with 4 other designers, and this is going to be an immersive project. So it's a project that is bigger than yourself. This is like a 4-meter high portal that people can cross, and the lights on this portal will interact with the people. But more about this later. Because right now I want to talk about Living Lab Stratumscience and how I went from the ideas that started this project and the actual solutions that I was able to find to make it happen. But what is Living Lab Stratumscience? I think this video will explain to you everything that you need to know. In Stratumscience, Eindhoven's crowded bar street, technology is used to keep people safe during the busiest days. The number of people entering or leaving Stratumscience and the noise they create while there are tracked using sensors. These sensors provide data to algorithms that can, for example, automatically detect violence and alert the authorities, or trigger special lighting that can reduce aggressiveness through subconscious cues from colored light. In the beginning of this year, a friend challenged me to create something interesting using creative coding and the data collected by CityLab, the entity behind these efforts. In my own memories of walking in those streets, noise, touch, and smell are among the most impactful sensations I remember. And since the data collected was created by people, the project should reflect that. The result of this collaboration is Living Lab Stratumscience, a generative design software tool that simulates the human footprint of visitors and paints the environment. A detailed 3D model of this street is used as a blank canvas, where virtual crowds roam around and leave their mark, like stepping on the floor or bouncing sound waves from a wall. In this data-driven tool, the origin and number of simultaneous crowds is dictated by the real data collected in that same street. A painting is the result of 24 hours of real data. At any point of the process, The user is invited to explore this digital 3D painting simply with a keyboard, mouse and a tablet, and customize several details of the painting, such as background, color palette, or the intensity of the footprint, among many others. A generative design tool can be seen as Photoshop, but unlike Photoshop, it doesn't require specialized knowledge, meaning anyone can use it, since the designer's artistic process is embedded into the tool. When the user is happy with the outcome, high-resolution photos and videos can be captured, all of them with a consistent look around the theme of human presence in Stratum Zeit. This media can be then used for different purposes: public or social media campaigns, dynamic identities for every bar in Stratum Zeit, each with a unique but consistent look. Most visitors of Stratum Zeit are not aware of the data collection that happens every day, or the privacy control that is subjected to. This project repurposes public data as a starting point for these paintings. So this was a bit of a quick introduction to this generative design tool. But the most important to understand for now is that you can see this as a program, as an app that runs on the computer, and a bit like Photoshop, you can create images but also videos with it. So you can interact with it, you can make choices with it in order to create some kind of new media that didn't exist before. And why a generative design tool? So before in my previous projects, like you mentioned, the light canvas, but also the Flint wearables, where the idea was not to paint with light, but to be able to wear, control, and customize light. Both of these projects were much more physical. And this is actually where I like to spend the most time at my work, is working on that border between the physical world, the world that we see, that we experience, that we touch, and the digital world, where we can use technology to really empower our capabilities. And this is where I would like to work as a creative technologist. But now I wanted to create or build something that was not physical, that didn't have all of the disadvantages and all of the extra work that you need to put into creating something physical. So I wanted to create something that only lived within the computer, that I only needed to develop software and no electronics, no hardware. And I wanted to explore how powerful can these tools be. So this is the starting point for Living Lab Stratum Zeit. And the inspiration for this project, like I said before, came from a challenge made by a friend. But when this challenge was made, I almost instantly said, yeah, there's probably something interesting that we can do with creative coding and the work that you are developing at CityLab. So at CityLab, there's a lot of technology, there's a lot of data collection. And one of the interesting things, or one of the interesting features to give to these generative design tools, is that they can be data-driven. So they can use existing data, and even real data, like in this case, as a starting point for something else. So this sounded like an interesting challenge. But besides this, like I mentioned before, I really love color and light. And the way how these algorithms communicate with the people in the streets is one of the ways is through colorful, colored light that has a subconscious impact on your behavior. So again, this also seemed very interesting. And finally, I've been living in Eindhoven for 8 years now, so I spent quite a lot of time in Stratum Zeit. So that emotional connection was also very much present. But then, now that I knew a bit what I was going to do, or at least the things that were my inspiration behind this project, how do I actually make it a bit more concrete? What can I make with this data, the real data, with the people that created this data, and all of this idea of just being in Stratum Zeit? Like I said in the video, the things that strike me the most in my own memories of Stratum Zeit are the amount of people around you, which results in a lot of touching, the amount of noise, the smell from spilling beer, from whatever happens in Stratum Zeit. So all of these things, I saw them as a human footprint. And The human footprint is just basically what you leave behind once you went through a place that was totally natural. So you always leave some kind of, literally maybe, a footprint. You can always leave some kind of waste behind you. And you can always leave some kind of pollution in the form of, for example, sound pollution. Not really physical pollution, but sound pollution still counts as a human footprint. But besides this, I also had real data, real numbers that I could work with to make something interesting. But at the same time that I was starting this project, I only had a sample of the data that CityLab collected, because at the moment this data is still private and anonymous, but I could only get a small sample. So I needed something more to work with, more data, more technological things. One of the places that I decided to search after I knew about its existence was data.eindhoven.nl. In this website, you have a lot of datasets, all of them public datasets, about Eindhoven. So you can think, for example, the number of trees in every neighborhood in Eindhoven, the amount of cars, the amount of monuments, the amount of apartments, the amount of criminality. So you have a lot of aspects about Eindhoven and about the people of Eindhoven that are now converted into pure numbers that you can use for many other purposes. So the first thing I did was to go to this website and see what can I find about Stratumseind that is available publicly in this website. Well, I was very surprised to and very happy to find out that there's a 3D model of Stratumseind, of the whole street, with a lot of detail that you can use for free in any kind of project. And until now, I had a lot of ideas, a lot of concepts, a lot of data, but I didn't really have something physical to hold on to. So this 3D model became the canvas that I was going to represent this human footprint. And in order to do this, I also had this sample of data that I mentioned that CityLab provided me. And in this sample, for example, you can see 3 days of this year, from the 21st of February to the 23rd of February, which were basically the carnival days during this year. And you can see clearly, for example, on Friday between 9 and midnight, you can see that there's a big income of people to Stratumseind. Same thing on Saturday between 3 and 6. That's when most people arrived at Stratumseind. So I had the canvas, I had this 3D model, and I had to represent these patterns in the data, these spikes in the data, somehow within that canvas and somehow with the human footprint. So this whole presentation is basically the steps that I had to do, or the ideas that I had, and how did I convert them into actual code, into actual programming that I could use to develop this software tool. Whenever I start one of these projects and I have conceptual ideas and I need to turn them into something practical, something that the computer understands, usually I go through 2 steps. The first one is to think like a person, and the second one is to act like a machine. The reason for this is that machines, the computer itself, cannot be creative, at least not at this moment for now. And it only does exactly what you tell it to do. It doesn't do assumptions, it doesn't do any subconscious work for you. So you need to think like a person, you need to be creative as a person, but then the computer is actually going to execute the instruction that you give it to. So the computer needs to be able to understand what you want it to do. And in order to start thinking like a person, I had this big 3D model of Stratumseind that I was looking from a bird's eye view, from an helicopter view. This didn't feel very human-like. This didn't resemble my own memories of Stratumseind. So the first thing that I did was to go at street level, at a person's viewpoint within this 3D model. And this already started to trigger some ideas. For example, if I wanted to represent the human footprint, let's start with something very literal. Let's represent literally a footprint within this 3D environment. How can I do that? Well, if I look around at this 3D model, I can recognize what there is. There's windows, there's light poles, there's walls. There's a lot of objects that I recognize as a person. However, the computer doesn't. So although I'm thinking like a person, I'm looking at this 3D model like a person, I have to think how to act like a machine later on. And this whole model, and most 3D models that you see nowadays, they are all made up of triangles. And when you combine a lot of triangles, because the triangle is the most basic shape that you can create, when you combine a lot of triangles, you can actually create any other kind of shape. And what is a triangle if not just 3 points in a 2D or a 3D space? So basically this is what the computer sees. Just 3 points that, when connected, they form a triangle. And when several triangles are together, they form a more interesting, complex object. So how can I represent this idea of painting this specific triangle, but not painting that one and not painting this one? So can I choose which triangle to paint? Because remember, in this list of numbers that you see on the left side, there's no information whether a triangle is part of the floor, part of a wall, part of a window. There's simply no information about that. So I need to figure that out on my own. And to do that, I found out that I could use a line triangle intersection algorithm to actually know if that triangle was the one that I chose. And think about it like this. My arm is now a line that goes from my shoulder to my hand. So I have the line. And all around me, there's triangles. So you can now start to test, if I point this way, am I choosing, which triangle am I choosing from? And this idea actually worked, as you can see in this video, where two of these crowds, and the crowds are represented by spheres in this case, where two of the crowds are just randomly pointing at the environment around them, and the triangle that one of the crowd at least points to is being selected, and you can see it as a bright red. So this idea of pointing and painting, yeah, that was actually possible. Next challenge. So if we're talking about people that move around in Stratum Zines, they need to move around, right? And in this video, I was still controlling things by hand. But the idea is that the computer and the program is able to do things by itself, that is able to create these paintings by itself, so I cannot be the one driving the crowds around. I need them to move autonomously and hopefully in a way that people actually move. Often when you want to create some kind of fluid behavior, some kind of things that feel more alive and more natural within the computer, within creative coding, you use Perlin noise. And Perlin noise are just random sets of numbers that have some kind of connection between them. So for example, you can think of Perlin noise as a number that has a connection with the last number that you picked. And in every frame, I'm asking these crowds to generate random numbers. And these random numbers are going to be used as a direction and as a certain force that pushes the crowds around. So now they are now being pushed by forces that allow them to do turns, smooth turns, like for example, like you would see in these bottom images. In this bottom image, the black and white, with all of those smooth, fluid lines. This is a behavior that you can simulate on the computer using Perlin noise. So I applied this technique to my spheres, and now they could actually start moving around in a way that felt alive, that it felt sentient. So I now had the ability to start painting the environment, and the crowds would move around on their own. However, just a few seconds after I started this simulation, I see one of the crowds going through a wall. And then just a few seconds later, there's another one just leaving the map, and realize that you have a 3D model that exists in an infinite space, infinite 3D space. So there's no reason why the crowds, if I don't tell it to, there's no reason why the crowds cannot go wherever they want. And initially, this was a bit of a shock when I saw the crowd going through the wall and outside of the map, because I was not expecting it. I was thinking like a person too much. Because think about it, whenever you go from your bedroom, from your room to your bathroom, whenever you walk around the physical world, you subconsciously avoid the obstacles. You don't really need to think in order to not go against the wall. However, like I said before, the computer does not do any kind of assumptions. It doesn't do anything that you don't explicitly tell it to do. So if I just told my crowds to move around in a natural way, but I didn't tell them that there's a wall there, there's a world around you. They simply don't know about it. And this kind of reminded me how it would be to be in a completely dark room where you want to find the exit, when you don't have any kind of awareness of what is going on around you. What do you do in this kind of situation? Well, the first thing I remembered was to use my arms as a way to feel the obstacles that are immediately around me, or even to feel the wall and try to follow that wall until I find the exit. However, if there's, for example, also some kind of stairs or low objects, you also use your legs as almost as arms in order to feel the obstacles on the floor, or even feel that there's no floor where you're putting your foot now. So I needed to kind of simulate this kind of behavior, or I would like to try to simulate it. And at the same time that I was researching how to do that point and paint kind of behavior, I learned that I could use the same algorithm, the line triangle intersection algorithm, I learned that this algorithm can also be used by autonomous cars in order to avoid obstacles that are anywhere on the road, and even to see other cars. So I had the algorithm, it was supposed to work, and I had the idea that I needed some kind of arms and legs for my crowds. I needed to give them awareness of their environment. Well, this turned out better than I expected, after a lot of bug fixing, yes. But with one arm, my crowds are now able to feel if there's a wall, if there's a light post in front of them. And whenever they feel something like that, they just turn away. Same thing for the leg. Now they are able to see if they are standing on solid ground, if they are standing on the 3D model, or outside of the 3D model. And in case they go outside of the 3D model, again, turn around and go back to your normal behaviors. So this actually worked quite well. The next step. Painting was happening, movement was happening, but one of the things that I knew that I didn't want to do with this project was that I did not want to create something that felt like a computer game. And usually with computer games, it's something that is fighting for your attention, that is trying to entertain you. So there's a lot of lights, there's a lot of noise, there's a lot of color. Yeah, just something to keep you hooked up. But this is a generative design tool. The idea is not to enjoy the interaction itself, but the idea is to create something that you can call art, that you are happy with, and that you created with the computer. So I needed to get rid of all of these random colors, and I needed to find a way to make sense of these colors. And the way how I did this was by using a color palette. And before, the crowds could just pick any color that they wanted and start to paint the environment. Now they can only pick a color from within this color palette that I give them. And for example, I can have a color palette with just one color. I can have a color palette with two colors, red and green, like you see there on the left. And the nice thing is that I found out about another algorithm that allows me to calculate the colors between two other colors that you choose in a more lively way, in a more livelier way. And funny enough, this is also an algorithm developed by Ken Perlin from Perlin Noise that we talked about before. And this one is called Smoother Step. And using this technique, which I also converted into a processing library that I'm making also available on my own website that anyone can use, I was now able to define ranges of colors, define something that makes sense within the application or within the image that I'm trying to create. So now, instead of having totally random colors, I start to have a bit more of a control over what is happening in this painting moment. So you have tones of yellow, you have tones of green, you have just a very extreme color palette with reds and greens only, and you can start to see that things start to make a bit more sense. However, it's still very colorful, it's still trying to catch your attention. That's not the idea. At this point, I already knew that I was going for something a bit more subtle, something a bit more like architectural drawing. So I needed a bit more faded colors. I needed more subtleness in these images. And one of the solutions that I found to do this was to move from an RGB color space into an HSV color space. An RGB color space is the way how technology, computers, printers, your phone, is the way how they define how a color looks like. So you have the amount of red, the amount of green, and the amount of blue. You have three numbers to define a certain color. If you change any of those numbers, you get a different color. Within the HSV color space, which stands for hue, saturation, and value, or sometimes hue, saturation, and brightness, you can now just use one number to pick the color, and you can use the two other numbers to control the saturation and the brightness of that specific color. So this was an easy way to go from something that looks a bit like neon into something that looks a bit more pastel, more softer colors. But until now, this painting was always happening in a very strong way. Once a certain crowd passed by a certain part of the street, that whole area became very colorful, too colorful maybe even. So if the idea was to show the patterns behind the data that I was using, these patterns, these spikes that we talked about before, they represent more people going over the same area compared to less people going over the same area. So in order to represent this difference, or in order to be able to visualize this difference between a lot of people and not many people, I used transparency. So now the crowds were painting the environment around them, but using a bit of transparency so that the more that certain area of the map is painted, the brighter it will look compared to everything else around it. And you can see this effect, for example, on the image on the left, where that area around the center of the map is much more bright than the areas on the edge of the map or on the edge of the 3D model. So most of my problems, most of the challenges were solved. But by now, because I was always adding a new feature and developing more code, more features, more numbers, in the end, I found out that I had about 40 different parameters that I could use to customize everything that is going on around the screen. However, 40 is just too much. You want to be able to create something in a bit more natural way without having to go over so many numbers. And one of the interesting things that I found out about generative design and this kind of creative coding, creating art with a computer, is that you don't want to be in these two extremes. One of the extremes is that you as the artist, you are doing most of the work and the computer is almost doing nothing. So you are deciding everything for yourself and you are not letting the computer do any decisions. That's one extreme. Second extreme is that the computer is doing all of the work. So the computer is choosing all of the values, whether they are random, whether they make some sense with each other, but you as the programmer or you as the user, you have almost no control over what is happening with your art. This is the second extreme. Actually, what you want to do is you want to be between these extremes. So you want to work with the computer and not instead of the computer. And you want to be able to have this kind of partnership. So although there's 40 different parameters that control everything that is happening in this world, some of these parameters will be controlled by the real data that was collected in Stratum Science, while the other ones are controlled by you, the person interacting with the software. And this interaction takes part with three objects. The keyboard, which you can use to move around the map. And this felt very intuitive because everyone knows what the arrow keys mean on a keyboard. And if you played some computer games, you know what the WASD keys are for. So now we could actually go forward, backwards, left, right, up and down as well. And all of this just with the keyboard. With the other hand, you could grab onto the mouse and you can now start to pick the best angle for the camera, much so like a photographer. So a photographer just walks to a certain location, then he still needs to find the right camera angle that is the most beautiful, that is what you're trying to capture. In this case, you do that using the mouse. Finally, after you found this sweet spot, this perfect spot that you want to take a picture of, you can actually now start to customize it to make it look like what is your definition of beauty. Is it with a black background? Is it with a white background? Is it with the colors that you're seeing now in this video, or with other colors, 2, 3, 4, 5? You have all of these options through the tablet that offers you a very intuitive user interface. And I was really happy to see these pictures are from the Eindhoven Maker Faire from this year. And I was really happy to see that people from all kinds of ages and backgrounds, they were able to very quickly get into this user interface or use these controls to explore the real world. And it didn't really matter if they understood what they were doing. What matters is that they could actually explore and see the changes on the screen and have control over them, even if they were doing it kind of randomly. It's still interesting, it's still fun. But then, now you've seen how to actually control what is going on the computer, on the software, on this app, but how can you get something out of it? What is its purpose? What can you make with it? So the output for Living Lab Stratum Science are videos and high-resolution images. And for example, these images, you can choose to print them on a normal paper. You can choose to print them on a bigger canvas and actually have what you would consider more of a piece of art in a real canvas that was also created by this software tool. But if you have an image, also why not print it on a t-shirt? That is also an option. And for example, think about the videos that you can generate with this tool. If you're doing social media campaigns, if you're posting something online, it often gets much more attention if it's a moving image, if it's a video, anything other than a static image. So Living Lab Stratum Science can also generate these kind of videos for you. And one of the most interesting things is that initially I told you that generative design tools can be seen as Photoshop. However, with Photoshop, you always need to do these changes by hand and then export the image. With Living Lab Stratum Science, because the purpose is much more focused, and because I can predict what is going to be happening with this tool, I can also give it the ability to generate 100 images with just one click, all of them different, but still aesthetically consistent. So you feel, then you know, if you see these 100 different images, you know that all of them came from the same source. And this is very important when you're, for example, doing branding and marketing. Again, these are some of the results or some of the creations that people did during the Eindhoven Maker Faire. And like I said before, I was really happy to see that everyone, independent of the age, background, they could really explore all the extremes of this tool. And I really mean extremes because even I was surprised by some of the things that other people created with this piece of software. And on another note, this is some of the research that I did on myself on this tool. Because the initial challenge was to create something interesting with creative coding and the work that is being done by CityLab. However, CityLab was started by Tinus Kanters, and Tinus Kanters is retiring this year. And he's a very beloved character around Eindhoven. A lot of people know him. He has done a lot of great things for the city. So actually the first product that came out of this tool was a gift for Tinus Kanters. And Tinus' favorite bar is Altstadt, the one you see here on the picture. Tinus' favorite color is blue, so I chose to go for a blue color palette. And Tinus' favorite piece of clothing, let's say, is a black t-shirt. So using these three things that I found out about Tinus, and using all of the parameters that I had available on the software, I was able to create something that is very much focused on Tinus, one single person. However, if your favorite bar is some other bar, there's still a possibility to create something interesting with that other bar, with that other area of Stratum Science. So this was a bit of an introduction on how do I solve some of the challenges that I'm faced as a creative technologist, as a programmer, and what kind of challenges do I face when I create art with the computer. But I hope that you enjoyed it, and if you still want to find out more about my work or about the kind of things that I do, you can visit my website in luisferreira.space, but also my Instagram, where I more quickly post things that I'm doing at the moment. Again, thank you for Eindhoven Festival, MadLab, and the Future Makers Factory for this opportunity to show a bit more of my work and, yeah, just share a bit. Thank you so much.